Hello and welcome to our session, Unleashing the Power of Nested Data. My name is Georg Traar. I'm the Head of Customer Engineering at CreateIO, the makers of CreateDB. And in this today's session, we're going to showcase how you can use CreateDB together with your semi-structured data and objects and arrays, and really just use them in your queries like you would use it in a relational database system without the need to flatten anything, without the need to transform anything. You can just really use semi-structured data. First, we're going to start out with a short introduction towards CreateDB so that we are all on the same page. CreateDB is really a distributed SQL database system built for real-time analytics that combines features and functionalities of various others, typically database archetypes. From the NoSQL side, you have the flexibility, the scalability aspect, you have the queryability, the ease of use of the query language from the SQL side, and you have the speed of the indexing and the ability to use full text indexing from the search engine side. The three main priorities of CreateDB are really first and foremost the performance. So you can run ad hoc queries in CreateDB across hundreds of billions of records in under a second. You can use columnar storage for hyperfast aggregations across really large data sets. And that's all possible through a fully distributed and scalable querying engine that is built on top of Apache Lucene. But not only performance is important, or performance is not everything if you can't really use it, or if it's not really flexible. And in CreateDB, we really also wanted to combine that by really just offering SQL as a standard language. Everyone knows SQL. You can use SQL today. You can pretty much use CreateDB out of the box. We combined that with the PostgreSQL protocol, really just to make it easy to work with many tools out of the box that would also work with CreateDB, and we just make it easy to get it started with CreateDB. And since you not only want since you typically not only have like relational data that would fit in your table, you might also have like objects, JSONs that you might need to work on. We can combine that with time series, geospatial, and full text data all in one system within CreateDB. We do offer CreateDB fully managed on the cloud and on the all three major open cloud providers. We do have a hybrid-based solution that you can run on your Kubernetes setup, but offers many benefits of the cloud solution. We also do offer various packages for on-premises, including an official Docker image, and this is, as I said, is fully open source. In terms of scalability and reliability, those should not be afterthoughts, especially in a production system. We're living in a world where it's really important to have systems highly available. So CreateDB can be scaled or can be run as a single node, but can be scaled to hundreds of nodes, analyzing petabytes of data. And you can all do that in a very free manner through built-in high availability and automatic failover, which really makes it a very free experience. But today we really just want to focus on object data. I'd say object data is everywhere. If we look at different kind of use cases, from IoT to monitoring to really any kind of marketing analytics, we find JSON data from web requests or from devices that reporting various values. And yeah, we really find it because it's a flexible format and it's an easy to use, it's readable and universal format. And we really thought, why not make it easier for you to really work with the data? You should not need to flatten it down to really analyze the data, but you should use your data streams. They're coming from MQTT, coming from Kafka. You should just be able to ingest it into CreateDB and work with them. And that's exactly what's possible with CreateDB. We do offer SQL with objects in short. So you can just insert your JSON document into a table in CreateDB and just select and aggregate and filter on any kind of object property like it would be a column in CreateDB, all without first transforming that. But enough of the theoretical part. Let's really jump into how that does look like. I'm just going to quickly switch over to my demo server. And what we really have here is an instance of CreateDB running locally in this case. It's a single node, and we're gonna just switch to the query console. I just deleted some old data. But as I said, CreateDB is really standard SQL compatible, means you can just use your SQL knowledge, can create a table, it's called my table, and have a name, have a text value, have an age, have an integer value. And you could create it if I not already created that before. So let's just create my table too. And as you see, just a plain simple SQL statement. But today we are not just doing simple SQL. We are really looking into another use case, and we're gonna pretend we are an IoT architect, and we're gonna design a table schema for IoT use case. So we're gonna create the table for our IoT data. All IoT data pretty much has a timestamp column, so we create a timestamp column. And next to the timestamp column, we want to collect data for our sensors. So yeah, what kind of sensors do we have? Let's say we have a temperature sensor, that's a float value. We do have a humidity sensor, that's also a float value. And then we might have another temperature sensor that is also a float value, and so on and so on and so on. And you could do that, of course, and in other systems you might need to do that to flatten down the values to really work with them. But as I said, our data is not coming in a flat manner from our system. It's reported in a JSON and it's transported by MQTT. So why not just store that JSON? And in CreateDB we can do that because CreateDB does offer an object data type. So what we're just going to do is going to create this IoT data table with a timestamp and an object sensor data. And of course, this table is now available, but we also need some data. So we're going to just create some values and insert them into our columns. And in this example, I'm going to start with 2023. And in May, and maybe just in the morning, there was some sensor data reported. And as I said, and as I've shown you before, you can just really insert a JSON document in here, and let's just do that. As I said, we have a temperature value. Temperature, what was the temperature that was reported? It was 20.3 degrees Celsius, and we have a humidity that was 55.5%. And often also in IT use cases, we just have some location data, right? And location data typically consists of two values. It's a longitude and latitude. And in this case, this data comes in as a subproperty or another JSON object. And yeah, just have a latitude here. That's 48.282, and the longitude of 16.3738. And that's really just the coordinates for Vienna, where I'm usually based. And I'm just going to insert that, and you see insert OK, everything works out. And if we go back to our table and select on that table, we can see that we have now the sensor data in there. And as you can see, it's still the structure is maintained. We basically have properties or subcolumns in here. And yeah, all the data is there. But yeah, in my SQL statements, of course, want to work with that values maybe. So what I can just do, I can just select on this object and use the subproperty temperature, and I get that value back. That's great. And I can, of course, also do that for my location, and I get back another object that consists of two properties. If you know CreateDB a little bit, you also know that CreateDB also does support geospatial indexing. And this is not really a geopoint yet, so we could write a manual query to change that and transform that. But let's use another functionality of CreateDB to replace a user-defined function, and we can just kind of call that to geopoint. and that's gonna take into a parameter. It's an object, and it returns a geopoint. We're gonna use JavaScript because JavaScript works straight with objects, and define our function to geopoint again in JavaScript in here. And this really returns just an array with the location and latitude extracted. And I'm a bit, I'm just gonna copy the location subproperty and the latitude, and let's see. Yeah, seems to work. At least we defined it correctly. If we go back now to our select query, we can take this function and we have an object in here and can just pass the object and get our location back, which I think is really great. Let's get in some more data in our example. So I just add 3 more rows, and you can see I can run that query again and I get 4 locations back. And yeah, so if I click here, I see, okay, we have a Stockholm geopoint, and the very first one, Tokyo. And yeah, so we can use objects to also manipulate and also transform them to other objects again. Of course, you can not only just select on data, you can use these properties also in filters. So if I just filter on the IoT data table, which sensors reported a temperature of more than 25 degrees, I can do that. I can use also the values in like any other column in an average. And yeah, that's another maybe very interesting feature that was just recently added, is that let's say your data, your sensor data is not needs to be updated, and you of course could like pull this data out and then do an update. But if I really just want to concatenate another property to that object, I can just do that by concatenating 2 objects. So what I'm just gonna do here, and I add another object with a pressure field and say this pressure field is 1014. And I'm just gonna run that query. And if we now look at that object, we can see that this object has been merged with the other object. So you can really transform and build up new objects in CreateDB without any external programming. What we also saw before is we have our geopoint function. What if we don't want to use that in afterwards, just in the select statement, but really want to already use the geopoint indexing? We can do that by looking at our table again, just show create table IoT data, and I'm just copying the table statement. And if you remember correctly, when we first started defining that, the table really only consisted of 2 columns, the timestamp and the sensor data column, which was defined as object. In CreateDB, there are like 3 different object types. There we have dynamic, there is an ignored, and there's a strict one. The default object data type is dynamic. And what dynamic really means is that on ingest, when you ingest new data, CreateDB automatically creates these subcolumns or subproperties and assigns a data type to it. It's really done to index the data and to really exit it in a very fast manner, like a normal column. In some cases, you might not want to do that, and you might say, okay, I want to define my columns the way I want to, because I want to have my temperature to be a double. You can use the dynamic data type and define it before, or you can also just use the strict data type and then also prevent from any new columns to be added. Last but not least, there's also ignored, which allows you also to pretty much insert any kind of object you want, but only the ones defined in this as statement will then also be indexed and can be used for very fast queries. So going back to a location data type, we have this as an object. But what we really want to do is we don't want to have an object for location, but we want to have it as a geopoint. So we're gonna add another subcolumn, gonna use the geopoint data type and use a generation statement and say generated always as to geopoint and refer to the location data from sensor data and location. And yeah, so we automatically create the geopoint on ingest. So what we don't really read now anymore is the dynamic properties of this object, because we're not going to use that indexing. So we're going to just change it to ignored. Going to change that back to dynamic for coherence. And yeah, if we create this table, just call it IT data new. That works. This table is still empty, so we're gonna just copy over the data from the other table by using a select now from IoT data. And if we now query on this new table, we can see that the object now also contains the geopoint. So if you want to use that as a geopoint, you can just select it and that again, sensor data, and take location geo, and we see here we get the geopoint, in this case Vienna. All right, so we have seen quite a lot already what you can do with objects. Let's switch our roles quickly, and we're going from an IoT architect into marketing analytics role. And what we really just gonna have is a collection of some web data and some page requests. Gonna create another table, and into this table we're gonna also just create or insert some data, really just to example URL that might be coming from a request, with all kinds of, from schema to hostname to, yeah, basically all kinds of elements that you would typically see in an HTTP request. Gonna insert it into the table, and what we're gonna do now, again, just select from web data. We can see that we have this information in here as a text. And of course, we could use a regex expression to just really filter out, for example, the hostname. But what CreateDB also recently added is the capability to use a function called parse URL. You can use your page URL, put it in there, and surprise, surprise, you get an object with all the properties of the deconstructed URL. So if I just want to select all the page requests that have a host name, then really just go to the www.example.com domain. We can do that, and we can filter on that, and we can use it that way. Again, if I want to just filter out specific values, I could deconstruct that object and also use it similar to the geopoint in my create table statement in a generation function. All right, I think in terms of CreateDB and basics of working with objects in CreateDB, we have covered pretty much everything. I think you really should try it out with your own data and experience what you can do with the built-in functionalities of CreateDB out of the box that you would typically only find outside. And as I said, CreateDB is available to be downloaded for free. You can use the documentation, We do have a community site. You can ask us any kind of question there. The really easiest way to get CreateDB is by using CreateDB Cloud. So just press the login button. You're redirected to CreateDB Cloud, to CreateDB Cloud console. And as you can see, you can get a free trial and just start CreateDB with a few clicks. That's it from my side for today for this session. I hope it was interesting. I hope you're gonna try out CreateDB. If you have any kind of further questions, don't hesitate to ask them right now or at the links I provided before. You can ask us in the community. You can contact me. Feel free to do that anytime. And I hope it was interesting. And thank you a lot for listening in and staying until the end. I wish you a nice